This is Unit 12, Lesson 1, Introduction to Probability. So probability is trying to find out what's the likeliness of an event occurring. So we're just going to go over some basic terminology. So an experiment is some process that occurs with well-defined outcomes. That might be like flipping a coin, rolling a dice. All right, an outcome is the result from a single trial of the experiment. If you flip a coin, then it might be, the outcome might be like getting heads or getting a tail. An event is a collection of one or more outcomes, and the sample space is a collection of all the possible outcomes. So if it's a coin, again, it's just heads or tails. If it was a die, which is a singular for dice, then the outcomes, they usually have 1, 2, 3, 4, 5, 6. So those are all the possible outcomes that are available. So exercise 1, we have an experiment where the spinner is spun. So you can see that there are 5 equal sections. The experiment is just going to be spinning the spinner. One possible outcome, it lands on a 5, but you could have picked any number. What is the probability of spinning the spinner and landing on an odd number? Well, the event is landing on an odd number. And my possible odd numbers are 1, 3, and 5. Okay, the probability, there's 3 ways I can land on an odd number, and there are 5 possible outcomes. All right, so that's how probability is going to work. We're going to write that basic definition down right here. So the basic definition of probability, the probability of an event E occurring is given by the ratio. The probability of E equals the number of ways E can happen. So this top number, the numerator, is the number of ways to get that event. And the bottom is the total number of possibilities. Okay, so E is the number of outcomes that fall in the event. The number of outcomes that fall in event E. And S is the number of outcomes that fall in the sample space. So basically all the number of possible outcomes that are available. All probabilities have to be a number between 0 and 1. Okay, if it's impossible, like if it's not going to happen, like in that spinner, what's the probability of landing on a 6? It's impossible because there is no 6. So if it's impossible, it's 0. If it's guaranteed, then it has to be 1, the probability. But all probabilities are a number between 0 and 1. We can express probabilities as a fraction, a percent, or a decimal. Right? So let's flip over to the next page. There are 2 kinds of probability, theoretical versus empirical probability. Theoretical is the number of favorable outcomes over the number of possible outcomes. Number of favorable outcomes over the number of possible outcomes. And empirical is the actual probability resulting from an experiment. So theoretical, like, is in theory. In theory, if I flip a coin, half the time I should get heads and half the time I should get tails. But that could be different from the probability resulting from an experiment. So exercise 2 actually has a coin. So a fair coin is flipped 3 times and the result is noted each time. The sample space consists of ordered triplets such as HHT, that would be heads, heads, tails, which would represent a head in the first tail, a head on the second toss, and a tail on the third toss. A good way to show different outcomes is from a tree diagram. So the first coin I flip, there's 2 possibilities. I can get a head or a tail. Now the second coin I flip, if I got a head the first time, the second time I can still get a head or a tail. If I got a tail the first time, the second time again you could still have a head or a tail. Now say the first time you got a head, the second time you got a head, the third time you still have a chance of getting a head or a tail. So see how this works? Each time, and these branches are showing all the different possibilities that you can have. So basically, I'm just going to list all these branches as ordered triplets and see how many they are. So I can get 3 heads. I could get a head, and a tail. I could get a head, a tail, and a head. I'm just following the branches. A head, a tail, a tail. I could get a tail, a head, tail, head, tail. So the tree diagram sort of makes sure that I'm not going to miss one of them. So basically, there's 8 possible outcomes. If you just count the last branches at the end, that will also tell you your possible outcomes. So sometimes they ask us to draw a tree diagram. Sometimes they ask us to list all the possible outcomes. What's the probability that I get all heads? There's only one time there's all heads, and there's 8 total outcomes. So the probability is 1 out of 8. Exactly 2 heads. Well, I'm going to highlight this for us. Exactly 2 heads. So there's one, and there's one. So 3 times. So 3 out of 8. All heads or all tails. I'll do that one in green. So all heads, all tails. Basically, the probability of all heads or all tails, the probability of all heads is 1 out of 8, and the probability of all tails is 1 out of 8. And when you have an or situation, you add those 2 probabilities together. And I can reduce, don't have to reduce, but I did. All right. Third example, I have a survey was done by a marketing company to determine which of the 3 sodas was preferred by people in a blind taste test. The results are shown below. Find the empirical probability that a person selected at random from this group would prefer soda B. So I'm going to look at soda B right here. Soda B. There's 24 people that liked it, and the total is 53. So I can leave it just like that. If I want to write it in decimal form, it's 0.45. I did that in my calculator. If I want to write it in percent form, I write 45%. So any of those 3 answers is fine. Okay. Now find the empirical probability that a person selected at random would not prefer soda A. So if it's not soda A, that means it has to be soda B or soda C. Soda B, we already know, there were 24 people. Soda A, there were 11 people. So that's a total of 35 over 53. And if I want to write that as a decimal, it's 0.66 or 66%. All right, I got some more examples on the next page. Just 2 more. So students in a math class tossed a 6-sided number cube whose faces are numbered 1 to 6. The results are recorded below. Based on this data, what is the empirical probability of tossing a 4? Okay, so I actually did an experiment versus just in theory. So tossing a 4 is right here. There were 6 people, and if I add up all these frequencies together, there were 30 total. So I had to add up all those together. So 6 out of 30. And notice they did not reduce it this time. A dartboard is shown in the diagram below. The 2 lines intersect at the center of the circle. The central angle in sector 2 measures 2 pi over 3. Now 2 pi over 3, I'm going to convert that to degrees. I do that by multiplying by 180 over pi. The pi's cancel. And 2 times 180 is 360 over 3. And that's 120 degrees. So this is 120 degrees. That makes this 60. This is 120 because they're vertical angles, and that's 60. And they want to know what's the probability that the dart hits the board will land in sector 1 or sector 3. Well, sector 1, whoops, my pen. Sector 1 is 60 out of 360. That's 1/6. And sector 3 is also 60 out of 360, which is 1/6. And notice it says 1 or 3. So I'm going to add those two probabilities together. Okay, 2/6, or maybe they write it as 1/3, and actually they did reduce it this time. Okay, so that's just a basic introduction to probability.